Alright, this section is on two-dimensional figures, basically polygons, area, and and circumference perimeter as well. Okay, so first off, what is a polygon? Let me move the slide here. A polygon, that's a closed figure formed by a finite number of coplanar segments called sides, and the sides have a common endpoint that are non-collinear, and each side intersects two other sides, but only at their endpoints. The vertex of each angle is called a vertex of the polygon, and a polygon is named by the letter of its vertices, written in order of consecutive vertices. So over here in the sample, they have a 1, 2, 3, 4, 5, 6-sided polygon. They are formed by segments that intersect, and they have a common endpoint. So if we look at segment GH and GM, their common endpoint is that point G right there. GH and HJ have a common endpoint right there at point H. All of these points right here that are the common endpoints, those are called the vertices, or if we're talking about one in particular, it's called a vertex. And the sides are simply named as segments. Polygons, they can be either convex or concave. If a polygon basically is drawn such that any point of the polygon is not on the interior of another angle of the polygon, then it is convex, otherwise it is concave. The way I think about convex versus concave, right, is with the concave part, it kind of looks like it caves in on itself. So if you think like a polygon like this, all right, this part right here seems to cave in on the polygon. So that's how to tell whether it's convex or concave. This polygon up here, polygon GHJKLM, that is actually a convex polygon because none of the interior points, none of the vertices lie on the interior of the angle. Like if K was over here instead of where it is, it would cave in. But it doesn't, so that's why it's convex. The big thing here to know is that the polygons are formed by things called segments. So if we were to draw a polygon like this, and it has like a curved surface, a curved sort of side or whatever, that's not considered a polygon. Right, so that one is not a polygon. Okay? Generally speaking, polygons, they're classified by the number of sides. Basically, for polygons having n or more sides, the polygon is simply called an n-gon. If a polygon has 3 sides, a 3-sided polygon is called a triangle. 4-sided is a quadrilateral. And then you could go through the process for 5 sides all the way up to 10 sides. We have our pentagon, that's 5 sides. Hexagon is 6 sides. Heptagon is 7 sides. Octagon is 8 sides. Nonagon, you write that right. Nonagon is 9 sides. And decagon is 10 sides. Okay? If we have a polygon with more than 10 sides, we will label it as an n-gon. So let me finish writing this here. So basically, if we have an 11-sided polygon, that would be called an 11gon. If we had a 159-sided polygon, that would be called a 159gon. Okay? Equilateral polygons, those are polygons where all the sides are congruent, and an equiangular polygon is a polygon where all the angles are congruent. Convex polygons that are both equilateral and equiangular, those are called regular polygons, and things called irregular polygons, those are simply polygons that are not regular. They could be equilateral, but they might not be equiangular, or vice versa. Perimeter of polygons, that's the sum of the lengths of the sides of polygons, and some shapes even have special formulas for the perimeter, such as a circle. The fancy name for the perimeter of a circle is called the circumference. Some formulas here for you regarding perimeter, circumference, and area. If we're looking at a triangle, the perimeter is simply the sum of the three sides, and the area is equal to 1/2 the base times the height of the triangle. Square, a square is an interesting polygon. It's a quadrilateral. It's a regular quadrilateral because all four sides are congruent, so it's equilateral, and all of our vertices, all of our interior angles of the polygon are right angles, so they're all congruent. So a square is a special type of quadrilateral, and we'll talk about that in chapter 6 about all the different properties of quadrilaterals. But the perimeter of a square is simply the sum of the four sides, so that's how we get 4s, and the area of a square is the sides squared. Rectangles, we have all the interior angles are 90 degrees, they're all congruent, but the length and the width are different, so opposite sides of a rectangle are congruent. So if this side here has length w, this side there has length w, and then these sides are congruent, so it's L. So the perimeter really is L plus W plus L plus W, and if we simplify that, we will get 2L plus 2W, and the area is just the product of the length and the width. Then for the circumference, there's two ways, or for a circle, the perimeter or circumference of a circle, there's two ways you could think about it. You could think about it as 2 pi times r, the radius, or pi d, where d is the diameter. And then the area of a circle is found by taking pi and multiplying it by the radius squared. These formulas here are going to come in extremely helpful later in this section. Okay. So for a few examples here, name the polygon by its number of sides, then classify it as convex, concave, or regular, irregular. So first off, we'll do the number of sides. Starting with this side right here, we'll work clockwise. That's 1 side, 2 sides, 3 sides, 4 sides, 5, 6, 7, 8, 9 sides. So this polygon has 9 sides. So therefore, it's called a nonagon. Now, convex or concave, think about, it might be easier to think about concavity first. Well, does this polygon seem to cave in anywhere? Well, it seems to cave in twice. It seems to cave in right here, and also on the flip side of it. So this one here is concave, and regular or irregular, what you need to check for there is to see if all of the interior angles are congruent or if all of the sides are congruent. If you can check both of those boxes off, then you could say they're regular. But I notice here that we have 1, 2, 3, 4, 5 sides that are congruent, 2 more sides that are congruent to each other, and another set. So all the sides here are not congruent to each other. So this one here is also irregular. So it's an irregular concave nonagon, to put it like that. Second example here, name it by the number of sides. Well, this is a four-sided figure, so this is a quadrilateral. As we'll classify it as convex or concave. Does this polygon seem to cave in anywhere on itself? Like cave in on itself? No, it doesn't. So it's convex. And then regular versus irregular. We check the box off because all the sides are congruent, but we don't know anything about these interior angles here. Okay? Because we don't know any information about those interior angles, we say it is irregular because all the interior angles have to be congruent as well. This type of quadrilateral we'll learn in Chapter 6 that it is called a rhombus. Okay, so that's a special name. But in our chapter here, first chapter, we'll just classify it as a convex irregular quadrilateral. Alright, next example, find the perimeter / circumference and area of the following. Right here we have a rectangle here, so let's do perimeter first. Perimeter is twice the length plus twice the width. Let's let the length be 4.6 centimeters and the width be 2.3. So that's going to be 2 times 4.6 plus 2 times 2.3. And when we simplify that, we get 9.2 plus 4.6, and when we add them together, we will get 13.8 centimeters for the perimeter. Now for the area, that's simply length times width, or 4.6 times 2.3. 4.6 times 2.3 is 10.58, or 10.58. And our units are centimeters, and area is always in terms of units squared. Okay. And I believe we have one more example. We'll find the area and circumference using the following figure here. We have a circle. So first off, the perimeter of a circle is called the circumference. Circumference is 2 pi r, or C equals pi d if you're given the diameter. In this case, the value 8 meters, that's a radius, so we will substitute into 2 pi r. And we'll get 2 pi times 8. 2 times 8 is 16 pi meters. That's an exact answer. And if we plug that into your calculator, 16 times pi, you will get about 50.27 meters. And then the area is pi r squared, so that's going to be pi times our radius is 8 squared. 8 squared is 64, so we have 64 pi meters squared. And if we were to enter that in your calculator and get a decimal, 64 times pi is 201, about 201.06 meters squared. The answers that you'll see through the textbook that I've posted, those will be written a few different ways. They might be written in terms of exact solutions. Alright, so those are exact answers, whereas the decimal is the approximate area or circumference. Okay. Personally, I prefer the exact answers over approximate answers, because when we get to trigonometry, and especially right triangles, I'd much rather you do exact answers, like in terms of pi. And then when you even get into the trigonometry part of Algebra 2 Trig, you'll be talking about exact values of the 6 trigonometric functions. You'll be talking, you want to be much more precise as you get a little older in your academic and mathematical career. So hopefully, through this video, you learned a little bit about polygons. Hopefully, all that worked out for you, and you're able to follow along. The slides will be posted online as well for you guys here. So, if you have any questions, let me know via remind, email, whatever you want, and I will get back to you. Okay. Thank you. Have a wonderful rest of your day.